Okay, so the slope, remember, it's not the x, it's just the number with x. So your slope equals 2, right? Which means that you're going to rise 2 and run 1. Do you see that? Yeah. Okay. And then your y-intercept. Your y-intercept is what? -1. So your y-intercept is -1. Okay. So that's because it's in slope-intercept form, right? Now, what happens when it's in this form? Well, you have a couple options. You either can follow a couple rules to find the slope and y-intercept, or your goal is to get y by itself, right? So that I can identify my slope and y-intercept. So what would I do to get y by itself? The first thing I would do. I heard someone say it's subtract. Okay, when you are isolating a variable, you want to first see, is there anything I can add or subtract away? And I can subtract 2x. And what I do to one side, I do to the other. So that leaves me with 3y equals -2x plus 6. And they become neighbors because they're not like terms. Does that make sense? Okay, then I divide. So I end up with y equals -2/3 x plus 2. Does that look and sound familiar? So from here, can you tell me what my slope is? And my slope is? And my y-intercept is? Okay, so we remember this vaguely for the most part. Yeah. All right. Because we're going to need that information. So today we're going to start solving systems using tables and graphs. Okay. This is going to be page 27 in your notes. So if you need to make a note to yourself so that you can stay on track where you need to be, you may want to do that. All right. So we're going to do some, hopefully still feels like a little bit of review. So what is the slope of a line? Anyone in your own words, what would you say the slope of a line is? When you hear slope, what do you think? It's x and y. Your slope is your change in your x and your change in your y. So in words, slope is our change in our y over our change in our x. And letters or characters, it would be delta y over delta x. In formula, that means that I have 2 points. So if I have x1, y1, I have x2 and y2. My slope would be y2 minus y1 divided by x2 minus x1. Okay. And ways that you probably, and like non-mathematical ways, y'all remember rise over run? Yeah, does that ring a bell? Rise over run. Did y'all ever hear fall over crawl? But sometimes you got to go down too, right? But those are just ways of calculating. But it's your steepness of your line, right? And changing your y over the change in your x. Okay, what is the y-intercept of a line? Well, the y-intercept of a line is where it crosses the y-axis. Okay, it's the value when x equals 0. So it's when it crosses the y-axis. It's the value when x equals 0. So there are three ways to represent an equation of a line. We have slope y-intercept form, we have standard form, and we have point slope form. Each way depends on the situation and also kind of is subjective on your comfort. So we have slope y-intercept form, and that's y equals mx plus b. That's the most common, the most comfortable, the most utilized, right? We then have our standard form, and our standard form is ax plus by equals c. And in this case, a is always positive. A is always positive. Oh, I didn't leave enough room. And A and B are always are integers. A and B are all, A is always positive and A and B are integers. Integers meaning that there are no fractions for A and B. No fractions, no decimals. And lastly is our point slope form. Point slope form is y minus y1 equals the slope times x minus x1. So point slope is is utilized when you're given a point and given the slope. Okay, questions so far? Anyone's like, I've never seen any of this in my life. Okay, cool, cool, cool. All right, our key concepts here are talking about the types of solutions that we can have, okay? So the types of solutions that can come about, there are three types. We have intersecting lines, we have coinciding lines, and we have parallel lines, okay? If I have intersecting lines, what that means as far as describing my slopes and y-intercepts. So if I have intersecting lines, so if the lines intersect, okay, that means that they have different slopes. That's it. Their y-intercepts could possibly be the same, but they have different slopes. Keyword is possibly. If you have coinciding, notice here how one line was blue and one line was red. Coinciding means that they're actually simplified down to be the same line. Because when you overlap blue and red, what color do they make? Purple. Okay, that means you have infinitely many solutions. Okay, it's a consistent system and it's a dependent system. Okay, so it's consistent and dependent. So when you have coinciding, so just one line, that means you have the same slope and the same y-intercept. Okay, same slope and same y-intercept. All right, lastly, we have parallel lines. And when that happens, you have no solution. It's an inconsistent system, okay? So when you have parallel lines, they're going to have same slope and different y-intercept. Okay, so they're going to have the same slope, but different y-intercept. So that's how we classify our system solutions. We have intersecting, one solution, it's a consistent system, an independent system. We have coinciding, it just ends up overlapping, looking like one line. There's infinitely many solutions, consistent, and it's dependent. And then we have parallel lines, they never ever touch, and there's no solution, and they're inconsistent. So if I have two equations of a line, and they have different slopes and possibly the same y-intercept, but generally different y-intercept, then they are going to intersect at some point, okay? If I have two systems and they have the same slope and same y-intercept, guess what? They're gonna overlap, they're gonna be coinciding. And then if I have same slope and different y-intercept, then we're going to be parallel and we'll never ever touch. All right. So we're going to talk about using a table to find the solution of a system, okay? When you're using a table or mapping or ordered pairs, any type of distinct data, what you're looking for is where are the x values the same, okay? So when is x the same? That's what you're asking yourself. When you're looking at the tables, the mappings, the ordered pairs, you're asking yourself, when is x the same? So looking at this table here, when are our x values the same? We have it 3. It's 3, 1, right? Because at x equals 1, are they the same? Nope. So what this tells us that our solution is 3, 1. Is that easy enough from a table? Now, if there's no point where x value, where the when is the x the same value? At no point, if that's the case, then that means that there's no solution, right? But clearly there is here, so therefore we don't have no solution. Solution is 3, 1, okay? Now, typically when you write the solution, you would just write x equals 3. And that's because I can look and see that they're the same. So this is the ordered pair. And this is more of your solution. Do you feel like you could identify the solution to a system from a table? Easy enough? Awesome. All right, let's talk about it graphically, okay? So when you have to graph, what are you doing? Well, these are the 4 steps to find the solution from a graph. 1, we're going to solve for y. 2, we identify and plot the y-intercept. 3, we identify and use the slope. And then 4, we connect the points, okay? So just like we talked about last week, you're going to still do the same things. So if I'm going to start with negative 3x plus 2y equals 8, that's going to be my first line. So I need to get y by itself. So we have negative 3x plus 2y equals 8. Okay, so we kind of reviewed this before we started. So what do we need to do in order to get y by itself? We need to move the whole term with x, right? So if it's negative, how do I move it? I'm going to make it a positive. And what I do to one side, I do to the other. So I'm left with 2y equals, and these become neighbors because they are not like terms. Okay, and then I'm going to divide by 2. So that tells me that my first equation is y equals 3 divided by 2, x plus 4. Agreed? Okay, so for this problem, my y-intercept is at 4, and my slope is, so here's my b. Uh-oh. There's my face. Here's my b. And here's my slope. So I'm going to go to 4. And at 4, I'm going to rise 3. 1, 2, 3. And I'm going to run 2. 1, 2. Rise 3. 1, 2, 3. Run 2. I'm going to repeat it, but this time I'm doing the opposite. So I'm going to go down 3. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. Now I'm going to make the straightest possible line that I can make. I'm trying real hard. Bam. Done. All right. So I'm going to do exactly the same thing that we did with the red line for the blue line. So we have x plus 2y equals -8. So again, what do I need to move first? The x term, right? So I got to move the x term. So my x term needs to become, it's positive, so it's going to turn into a negative. So we have 2y equals, again, there's just neighbors, 2x plus 8. And now I'm going to divide by 2. And I'm left with y equals -1/2 x plus 4. Oh, it's a -8. Lo siento. There. So it's at -4. So this time, my b is at -4. And my slope is, I'm going to go down 1 and then right 2. Do we see that? So b is at -4. So I go to -4. And this time I'm going down 1 and right 2. So down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Now I'll repeat the process. This time I'm going to go up 1 and left 2, 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 up 1 and left 2. Now I'm going to do my very, very best to make a straight line for you. Use your imagination. I went through every single point. Do we see our point of intersection? Yes. Where's our point of intersection? -4, -2. So our answer is -4, -2. Okay. How do we feel? It's a little tedious, huh? But doable. Questions, comments, concerns? None? Yay. Okay. All right. So here we have a real world scenario, whichever the word is. The diagrams show the birth lengths of growing rates of 2 species of shark. If the growth rates stay the same, at what age would a spiny dogfish and a Greenland shark be the same length? Okay. So the first thing we have to do is write the equation. So if we're going to write the equation here, we have to identify what's our slope and what's our y-intercept. Okay. Key thing to know when you hear the word slope. Slope equals your rate. So when you see the word rate, that lets you know it's your slope. So for the Greenland shark, my slope is 7,500, right? And it's birth. So when you hear the word, think about your y-intercept, you should think of beginning. Where do you begin? Where do you start? So is your birth your starting point in life, right? So his birth is 37 centimeters. So that's my B. So my equation of my line would be, we're going to call this Y1. equals 75 hundredths x plus 37. Do we see how we came about that? Okay. Now for the spiny dogfish. So for the spiny dogfish, its birth and its growth are right here. So my M and my B. So my Y2 is going to equal 1.5 x plus 22. Questions about how we created the equation? Easy enough? All right. So we're going to go to Desmos. And we're going to find out via technology where these two graphs will end up intersecting. All right, so you should have gotten here. And we're going to put in our first equation. So we have 75 hundredths x. And it's going to be plus 37. Click on graphing. Click on graphing. Yeah. It can look like this. Mm-hmm. Okay. All right. So notice how I do not see it, right? So I don't see the graph, but that's just because I have a very large number. So my B starts at 37. So if I need to zoom out. So if my B starts at 37, I'm going to have to zoom out. Do I see a graph now? Yes. All a matter of zooming out. Don't freak out. Then I'm going to put in my Y2. And my Y2 is 1.5 x plus 22. Okay. And bam, I can click where they intersect. So if you're on your phone, you have to zoom in. If you're on the computer, you just take your mouse, hover over it, and you can click where they intersect. So they intersect at 2052. So we got to figure out, what does the 2052 represent? That's what we're going to talk about. What does the 2052 represent? It's our solution, but what does it represent? So we ended up with 2052. Okay, so it means when they're going to be the same size. So at 20 years old, right? Because it's our growth rate. I'm sorry. They grow centimeters per year. So the centimeters is our Y, and our, so this is centimeters, and this is years. So this means that in 20 years, they both will be 52 centimeters. Okay. When you have a word problem, you're going to respond typically in a sentence with what the answer to that word problem is. All right. What I want you to do is look at the graph and talk with your table. After 25 years, what would be the length of the two sharks? So after 25 years, what would be the length of the two sharks? And then at what point is the spiny dogfish shark longer than the Greenland shark? So what are their lengths after 25 years? And at what point is the spiny dogfish longer? All right, so if you notice that on here that we don't have a table like we would normally have a table, right? And so, I hope I do this right. I'm always trying to remember how to do it exactly. All right, so if you label them Y1, if you label it, I forgot to do it. Do I put the little tilly mark? I just had a brain fart, guys. Oh. Oh my gosh. I'm trying to remember what I do. I think I'm having trouble remembering. Oh my gosh. Try to make the Desmos table come up. Oh goodness. I'll have to come back to you this. I forgot how to make the Desmos table come up. I don't know how I forgot that because I really don't use it that much. Okay, but there's a way to make the table come up and we will go back over it. But the beauty about this is that you can actually just hover. So if I am looking for 25, notice how I can slide along. And for my Greenland shark, after 25 years, it's at 55 and 75 hundredths. Do we see that? And then for my, what's the other shark called? Spiny dogfish, it is at 59, right? 59 and a half. So there's my spiny dogfish value. And so when we're talking about the two, so we're talking about them. Oh, okay. We were done? Okay. I wasn't, but cool, cool, cool. Maybe they'll let me write on it still. Nope. Talking to me. All right, so here, what do we get? We got, I'll type it in. Green, is it okay if I just write green? I think that's what it's called. The green one is, how long? 55 and 75 centimeters. And then our other guy is the spiny, 59 and a half centimeters. Okay. And it's the last thing we were going to figure out is at what point is the Greenland shark longer? So you're looking for at what point is the spiny dogfish? So graphically, we're looking for when does the spiny dogfish overpower that line? So when we look here, that's at 20, right? So after 20 years, no matter what, the spiny dogfish is going to be bigger. So the answer is after 20 years. So after 20 years. All right. That concludes today.